Let's take a look at question 3 of this A-level further statistics paper from 2024. Question 3, it asks, Theorem took a survey of students' favorite colors. The results are summarized in the table below. So we can immediately see that it's a contingency table. It's probably asking us to do a goodness of fit test. So underneath the table, we see Theorem carries out a suitable test to see if there is any association between favorite color and year group, etc., etc. That's the full question. Let's try and answer this question step by step. First of all, part A is asking us to write down a hypothesis for a suitable test. Now, let's try and look at the question again. It's asking us to carry out a suitable test to see if there's any association between favorite color and year group. The answer is actually given in the question. So our null hypothesis is going to be that there is no association between favorite color and year group. Apologies for the handwriting. And then the alternative hypothesis is simply that there is association between, let me highlight, there's no association in the null hypothesis, favorite color and year group. Okay, so that's part A dealt with. So some of you might be wondering, why is it that the null hypothesis says there is no association and the alternative hypothesis says there is association and not the other way around? The reason is that normally for the null hypothesis, we assume that there is nothing special. So for example, it's like in a courtroom, someone is innocent until proven guilty. So it's for us to prove if there's any association between favorite color and year group. Therefore, our base assumption is that there is no association. Looking at part B, for her table, Theorem only needs to check one cell to show that none of the expected frequencies are less than 5. B1, identify this cell giving your reason, and 2, calculate the expected frequency for this cell. So you might not have come across this before. It's asking us to check the expected frequency and that there is only one cell. So let's maybe ignore the fact that it's telling us to check one cell, but let's have a think about how do we work out the expected frequency and why is it saying that I want to be checking whether the expected frequency might be less than 5. You might recall that when we want to do a chi-squared test, we need to make sure that the expected values are more than 5. And if they're less than 5, we need to be combining some of the frequencies. So let's take a look. So in order to work out the expected frequency, we simply look at the column total and multiply that by the row total and divide that by the total number of observations. For example, if I want to know the expected frequency of the number of year group 1 to 5 students who like the color red, and I multiply 62 by 88 and divide that by 240. In this case, I get an expected frequency of 22.7 using my calculator. Okay, so this is how I work out the expected frequency. So you can see that, well, 240 is fixed. If I want to see the lowest expected value, so I simply need to find out, so which one is the lowest column total and which one's the lowest row total. So let's take a look. Lowest column total, let me use a slightly different color. Lowest column total is 19 here, and lowest row total is 68. And therefore, I just need to check this cell here, and I can see whether the expected value is higher than 5. If the expected value here for year group 10 to 12, whose favorite color is black, if that expected value is higher than 5, then I know that all the expected values are higher than 5 because For all the other cells, this calculation is going to be higher than what I'm about to work out. So let's work that out. So B1, identifying the cell. So that cell is year 10 to 12 and black, because it has the lowest row total and lowest column total. Okay? And part 2 there asks us to work out the expected frequency. So as I explained earlier, so it's simply the column total, which is 19, multiplied by the row total of 68, divided by the total number of observations. Using my calculator, that gets me to 5.38, which is greater than 5. Part C, we've been told in the question that the test statistic for the test is 38.449. The question is telling us to use a 1% level of significance and complete the test, state my critical value and conclusion. So it's useful to highlight what is being given in the question and what's being asked for in the question. As I said earlier, this is a contingency table. And when we do a chi-squared test, we need to work out the degree of freedom. In a table with R rows and C columns, the degree of freedom is simply, so that part C, degree of freedom is R minus 1 times C minus 1, because there's one constraint for the number of rows and the one constraint for the number of columns. Therefore, number of rows is 3. So it's 3 minus 1. Number of columns is 5. 4 is 2 times 4. So we've got 8 degrees of freedom. Now, let's take a look at our statistics tables. Now, this is the page where I have the percentage points of the chi-squared distribution. So I had degrees of freedom of 8. And the question is asking me to use a 1% level of significance. So the critical value that I need to be looking at is chi-squared with degree of freedom of 8 and 1% level of significance. So let's take a look at our tables. We're interested in a degree of freedom of 8 and a 1% level of significance. Therefore, the intersection there is 20.090. So that's the critical value that we want to use. So that is what we got from the tables. And this is less than the test statistic, which means that the difference between the observed values and the expected values are much greater than the critical values. So there is evidence to reject our null hypothesis. There is evidence to reject H0, that there is no association between year group and favorite color using 1% level of significance. That's our question 3.